Now, if you've watched any of my videos as of recent, you probably know I'm a huge fan of Docker. About 90% of the applications running in my home lab are running through Docker containers. Whether that be my media server, analytics tools, web services, or download clients. Now, in this video, we are going to go over the why, the how, and some of the basics that you need to know to get started using Docker and implementing it into your home network. But first, what is it? Now, Docker is a platform that allows you to work with containers and containerized applications. In the world of software and servers, a container is an isolated environment that generally has a single primary application running inside of it. Containers allow developers and system administrators to create and deploy reproducible images that are similar to packages from a distro's package manager. However, containers don't rely at all on libraries or dependencies from your host system. They come with everything required to run a given application in a known working configuration. Now, in addition to the dependency benefit, using Docker and containers makes it really simple to deploy and manage services since they're isolated from the host system. Whether that's bare metal or a virtual machine, containers also make tearing down and cleaning up easy, so they're a great way to experiment and play with various software and services. So, how do we get started using Docker? Now, in general, when I use Docker, it's usually integrated into whatever operating system I tend to be using. Currently, in my Unraid instance, Docker containers are installed through the application page, and when you install it here, you see a lot of variables that we're going to kind of touch on a little bit later. But once something is deployed, these applications are going to be managed through the Docker page because they're really just Docker containers. I also have a bare metal Ubuntu server that has Docker installed on it, and installing Docker on Ubuntu server is pretty easy. You just have to install with apt using the following commands. First, always update your system with sudo apt update, and then we're going to do a sudo apt install docker.io. If you want the most up-to-date version directly from Docker, you can also install it from the official repositories that Docker provides. For most major distros, including Ubuntu, find the instructions in the Docker's documentation that will be linked down below. You can also check out the convenience script for one of the simplest and easiest ways to install it on your system. And once that's done, any future updates will be available through your normal apt update. Once it is installed on Ubuntu, the Docker systemd service will automatically be started and enabled, so Docker will start automatically if the system is ever rebooted. And you can check to see if it's running with the following command, that is a sudo systemctl status and Docker. Here we can see the service is active and it's not throwing out any errors. So now, one step in the Linux post-installation steps in the actual documentation is to manage Docker as a non-root user. For this, you can add your user account to the Docker group, and this allows you to run commands without needing to use sudo every single time. However, it is important to note that adding the user to the Docker group grants some significant privileges, as Docker allows direct access to the host system. Therefore, exercise caution when granting Docker access to non-root users, as it can potentially lead to security vulnerabilities if not properly managed and monitored. Now, if you want to do this, run the following commands. We do a sudo group add docker, and there's a chance that you will already have that group. And then from there, we are going to do a sudo usermod-ag docker, and then the $ all caps user. This is a filler for your current user. Once you run that command, it should look a little something like this. And then if you log out and log in, it will be activated, or you could run the new grp space docker command to activate the group changes immediately. And now we won't have to use sudo for Docker anymore. After that, a way to test that everything is working properly is to run the hello world container, and we're going to do this with docker run hello world. Docker's run command takes the name of a Docker image as its argument, in this case hello world. If needed, it downloads the image and then creates and runs a container based on that image. Downloading images is known as polling, and you can also pull an image manually using the pull command, and this can be useful for getting a newer version of an image or initiating the download of a large image for later use. For example, this command pulls the latest version of an Ubuntu container, docker pull Ubuntu. We can then run the Ubuntu container as an interactive session using the -it argument. Since the image is already pulled, this container will basically start automatically. This drops us into a bash shell running a fresh Ubuntu container, and there's a full Linux file system and basic commands including apt are available. So yes, we are running Ubuntu within Ubuntu. And to go ahead and exit this container, all you need to do is hit Control D. Now the command docker ps gives us a view of the containers that Docker is currently managing. By default, it only shows running containers, so the Ubuntu container won't show up since it is now stopped. But by adding the -a flag, all of the containers, even the stopped containers, will be shown. One thing to know about containers is that just creating a container doesn't take up any extra space. Docker works by creating layers on top of the pulled image as files are added or modified. Removing old containers is still a nice way to keep things nice and tidy, and that can be done by running a docker rm command with the container ID or the name of the container that we saw shown in docker ps earlier. Now, when we don't add a name variable, when we fire up a container, it will randomly generate one. So next time I run this Ubuntu container, I'll be sure to give it a creative name. Now, when containers are removed, any changes to the container, including stored data, will be lost. In general, containers are considered disposable, and it is expected that they will be periodically replaced, such as during updates. So any important data that the container uses or generates should be stored separately. Docker provides two main mechanisms for storing data persistently on the host system, that is with volumes and bind mounts. Volumes provide a dedicated storage space that can be referenced by name for later use, and then bind mounts, on the other hand, are a way of giving the container access to a limited scope of the file system on the host. Bind mounts are what I end up using more than anything, as my main use case back there is sharing media that I have on some of my network shares with various Docker containers. For example, many of my R applications have identical binds so that they work better together. But first, let's touch on volumes. These can be added to a container by adding the --volume flag, or -v for short, to a docker run command. For example, we could do docker run -it, give it the Ubuntu name, and then --volume, we're going to name this volume test, and we're going to mount it to /mnt within Ubuntu. So then the volume name test will be created, it will be mounted there, and now that we are in the container shell, we can create a file inside of that volume. We're going to do this with an echo test into the proper location, and then after we exit the container shell with Control D, we can see the volume created by listing the volumes with docker volume ls. By default, Docker stores volumes on your host system within these subdirectories of var, lib, docker, volumes, and we can access the contents like any other file, but we will need to use sudo in this case since the location is owned by the root. To go ahead and make sure that it is there, we can run a sudo cat command into the proper directory /test_data and test. And then we can see it's there and we have access to it. Anytime we give the same volume name to a future Docker command, it will use the same volume and the same data will be available. Also, if we want to remove volumes, it's a simple docker volume remove test. And in this case, you can see my volume is still in use. The volume associated with it is the Ubuntu container, so I'll need to go ahead and remove it. And I could just do this with a docker container remove command, but I want to remove all my stopped containers in this instance, so to do this, I'm going to use a prune command, running docker container prune. It will ask me if I want to remove them, and I will say yes in this case. Now, do know, this is a command that you want to be careful when you use. The prune command also works with images, volumes, networks, and, well, everything. Here's another example to see how bind mounts work. In this case, we're going to mount the user home directory to the host system in the container. The invocation is very similar with volumes. We just substitute the host path in place with the volume name. So in this case, we would do docker run it for interactive, naming it Ubuntu. And for the volume, instead of giving just a generic volume name, this is going to be pointed in our host system to the directory /home/Brandon. And we're going to be mounting this in /mount, and it should show my host user folder. And now that we launched the container, we can see if that folder is available by running a ls/m&t command. Now, be careful with bind mounts, since any changes the container makes will also be permanently made on your host system. So generally, it's a good idea to give containers access to the minimum necessary set of files and folders from the host. So now we're going to go ahead and move on to the network side. Docker provides a networking stack that can isolate containers from each other and the host system on the network level. By default, containers are added to a default bridge network where they can communicate with each other but can't reach the host system or any other devices on the host network. Ports from specific containers can also be exposed to the outside world if that port is open in the host system's firewall as well. Then it becomes a service on a host's network. When using Docker run, a port can be exposed using the P option just like this. Let's run a Docker run-p. We're going to run this in the port 8080, semicolon 80, and we're going to be testing this with Nginx. Now the two numbers separated by the colon are the port numbers. In this case, the port 8080 on the host is mapped to the port 80 inside of the container. So to check to see if it's working, we can open our browser and enter localhost port 8080 in the address bar, or for a remote server, after opening the firewall for Nginx, we replace localhost with the service IP or the server's IP or domain. If everything is working right, the welcome page for Nginx should load. And it's also important to note, whenever configuring a Docker container, when you are changing the port in which a application or service is accessible on, always change the first half and not the second half of the port, because that can cause some breakage. And of course, like anything else, this is just skimming the surface of all this, so there'll be a link to a ton of documentation down below. Now, Docker's other primary network driver is called host networking, and this gives containers direct access to the network stack of the host. This mode provides some benefits that are especially helpful when high performance or low level networking operations are required. This is also conceptually simpler but less flexible and potentially less secure since the containers aren't isolated. Here's a previous example with some host networking. We just run docker run net equals to host and Nginx. In this case, Nginx will bind directly to the port 80 on the host and should be reachable from a web browser just by typing localhost on the host system's IP address. Now, probably my favorite, and that is Docker Compose. Now, when you go spin up a container, you may see a normal Docker command like this in whatever application's documentation. But if you see this instead, this is to be used with Docker Compose, primarily a system of orchestrating groups of containers that work together. For example, a web application might include a database and a web server, and each of those run in separate containers as part of a single Docker Compose deployment that's managed as a single unit. Now, personally, I use it even with a single container because it's kind of easy to edit the command variables, but that's besides the point. When using Docker Compose, containers in the same deployment by default share a single Docker bridge mode network that is separate from the usual default network. Each container gets an IP address in a subnet unique to that network, and Docker also provides a DNS system so containers can resolve the IP address of other containers using their container name. Each group of containers managed by a compose is defined in a docker-compose YAML file. In the simplest form, this file just specifies names for each container and which image they use. Networking, volumes, and many other options can be specified as well to control the behavior of the containers and how they work together. Many Docker Compose files are available online and they are easy to get started with. Just download the docker-compose YAML file, navigate to the folder where you saved the YAML file, and after any necessary edits, run docker compose up-d. This single command will take care of setting up everything as defined in the YAML file, and the -d flag tells Docker to run the deployment in the background and return control of the host shell. Logs for the containers won't be printed to the console in this case, but can be accessed with Docker Compose logs. Now, to stop a Docker Compose deployment later, just run Docker Compose down. This will stop and remove all of the containers. By default, the data stored in the volumes is retained, but you can also remove the volume data by adding the -v flag with Docker Compose down -v. Now, containers can only be removed when they are stopped, so it's sometimes necessary to stop a running container before removing it using the docker stop command, docker stop whatever the container name is. If stop doesn't work, killing the container may also sometimes be necessary, and that can be done with docker kill and again the container name. This can be compared to closing out an application normally versus doing a end task within Windows Task Manager. The basic method for updating a container is to pull a newer version of the container image, remove the container, and then start a new container using the new image version. This is one reason that storing data inside of a volume or a bind is important, as it's the only way the data can survive this process. Now, something I use, Watchtower, is a service or Docker container specifically for keeping containers up to date, which itself runs in a container. It detects whether if there is a new version available and replaces containers automatically with that new version using these same settings that they're created with, and it's what I have been using outside of Unraid, and it has been working great for my setup. And if you're interested in learning more, and it also has some options and configuration, you could check out their official documentation. And I will note, if you're setting up like a production environment, having containers automatically update might not be the best thing, so do keep note of that. So now you should have a nice base level knowledge of Docker necessary to start managing applications and services. If you want to dive into even more, there are a ton of great videos out there with much longer, way more information, and I'll link to some of my favorites down below. And with all that, I hope you have a good day. If you do enjoy this type of video, please let me know down below. And if there's any tips, tricks, anything that I left out that you think should have been included, please leave it down below in the comments. And if you're watching Learning Docker, do go check out the comments. So with that, don't forget to subscribe for more content similar to this. I hope you have a beautiful day, and goodbye.